In this video, we'll learn part 2.4 Factorization of Polynomials in chapter 2 Polynomials of class 9 CBSE. We'll also be solving exercise 2.3 questions. Before learning factorization, we need to know what is remainder theorem and what is factor theorem. Let's take a look at remainder theorem. Now, remainder theorem says that if p of x is divided by x minus a, then the remainder is p of a. Let's look at an example to understand this better. Example, p of x equals to x square minus 4x plus 3. What is the remainder theorem telling us? If this p of x were to be divided by x minus a, that is, let's say x minus 2 for example, then the remainder of this division should be p of 2. So, to find the remainder on dividing by x minus 2, we need to find p of 2. So p of 2 is nothing but substituting 2 in the place of x. 2 square minus 8 plus 3, which is 4 minus 8 plus 3, which is minus 1. So this minus 1 is the remainder that you get upon dividing x square minus 4x plus 3 by x minus 2. Factor theorem is just an extension of remainder theorem, or you can also say it's a special case of remainder theorem. Factor theorem states that x minus a is a factor of p of x if p of a equals to 0. In the earlier example, we got p of 1 as minus 1. If it was equal to 0, then you could say x minus 2 was a factor of the given expression. For example, here we have an expression x square minus 4x plus 3. In order to know x minus 1 is a factor or not, we can use factor theorem. How can we do that? We can substitute x equals to 1 and see the value. Now on substituting x equals to 1, I get 1 minus 4 plus 3, which is 4 minus 4, which is 0. So I can say, according to factor theorem, x minus 1 is a factor of x square minus 4x plus 3. Let's take a look at another example. Is x plus 2 a factor of x cube plus 3x square plus 5x plus 6? If x plus 2 is a factor, then x equals to minus 2 should give me 0. Upon substituting x equals to minus 2, I can see that the value is coming to 0. So, I can say x plus 2 is a factor of the given polynomial. The main goal of this part of the chapter is for you to learn how to factorize polynomials. Let's start with learning factorizing quadratic polynomials. What is a quadratic polynomial? If you remember, the degree of a polynomial is equal to 2 is called a quadratic polynomial. Here, x square minus 5x plus 6 is the example of a quadratic polynomial. Now, how to factorize it? You can either factorize it using splitting middle term method, or you can factorize it using factor theorem. Let's see splitting middle term method first. In this method, we write x square minus 5x plus 6 as ax square plus bx plus c. Now, we find a into c, which is 1 into 6 will give me 6. Then we also find the value of b, which is minus 5 from the expression. Now, we need to find two numbers that multiply to give AC, but then when you add them, they have to give minus 5. How to find them? You can start with taking factors of the number 6 here, that is AC. So, I know factors of 6 as 1 and 6, 2 and 3 also give 6. Now, see which of these numbers have the difference of minus 5 and they multiply to give 6. So, I have taken 2 and 3 here, where if I multiply minus 2 into minus 3, I will get 6, and if I do minus 2 plus minus 3, then I get minus 5. So, my condition is satisfied. Split the middle term, that is 5x over here, using these. So, x square minus 2x minus 3x. So, minus 2x minus 3x is nothing but minus 5x. I have just split it and written in this form. Now, take x as common for between the first two terms. I get x into x minus 2, and taking minus 3 as common in the second two terms, I get minus 3 into x minus 2. Now, taking x minus 2 as common, I can write x minus 2 into x minus 3. So, I am able to write this polynomial over here in terms of its two factors, x minus 2 into x minus 3. Now, let us take a look at solving the same question using factor theorem. Now, x square minus 5x plus 6 Factors of 6 are plus minus 1, plus or minus 2, plus or minus 3 and plus or minus 6 as we have seen. You can check if these will be the factors of the given expression or not. Usually it is easy to start by taking a into c, which is 6, and writing down its factors and checking for it. Now check if x plus 1 is a factor. So x equals to minus 1. Upon substituting, I get plus 12. This is not equal to 0. So x plus 1 is not a factor. Now check if x minus 2 is a factor. So I have to substitute x equals to 2. Upon substituting x equals to 2, this expression becomes 0. So yes, x minus 2 is a factor. Now check if x minus 3 is a factor. So upon substituting 3, the value is again 0. So x minus 2 and x minus 3 are the factors of the given expression, and I can write it in the same form. So as we can see here, either you use splitting middle term method or the factor theorem, you're going to get the same answer. Usually we prefer using splitting middle term method for quadratic polynomials as it eliminates the process of trial and error that we go through factor theorem. However, the same splitting middle term method cannot be used for cubic polynomials. For these, we use a combination of factor theorem and long division, and then we use the splitting middle term method. Let us see step-by-step process on how to factorize cubic polynomials. Here cubic means the degree of the polynomial is 3. First example is shown here, x cube plus 3x square minus 4x minus 12. Now take coefficient into constant, that is the first coefficient into constant. A into c here is minus 12. Now factors of minus 12 are 1, 2, 3, 4, 6 and 12. They can be either plus or minus as we know. Now check if x equals to minus 1 is a factor. Upon substituting, I get minus 6. This is not equal to 0. So x equals to minus 1 is not a factor. Second, check if x equals to minus 2 is a factor. Upon substituting x equals to minus 2, I get the value as 0. So x plus 2 is a factor. This is the first step. After we know that x plus 2 is a factor, we perform long division. Performing long division of x cube plus 3x square minus 4x minus 12 with x plus 2. Let's see how to follow this process. This long division can be performed in a similar way that we do the regular long division. We just write x plus 2 here and see that here we need to get x cube. So check what you need to multiply to x plus 2 to get x cube. I know that I need to multiply x square, but I need to multiply it to whole x plus 2. That gives me x cube plus 2x square. So I write x square here and x cube plus 2x square here. Upon subtraction, I am left with 3x square minus x square, that is x square. X cube get cancelled. Now bringing this minus 4x down, I need to multiply something to x here, that gives me the first term, which is x square. So x plus 2 into x gives me x square plus 2x. Now upon subtraction, I am left with minus 6x, and I am bringing this minus 12 down. I have minus 6x and minus 12. Now I need to see what I need to multiply to x to get minus 6x. I can multiply minus 6. So upon multiplication of minus 6 into x plus 2, I get minus 6 minus 12. Now this whole thing gets cancelled and my remainder is 0. Now I was able to divide my whole polynomial, that is x cube plus 3x square minus 4x minus 12 into x plus 2 into x square plus x minus 6, which is my quotient. Now I need to use splitting middle term method in order to factorize this, so that the whole expression can be factorized. Now in order to factorize this, I have AC equals to minus 6 and B equals to 1. So plus 3 and minus 2 satisfy the criteria to split the middle term x, because 3x minus 2x will give me x. However, 3x into minus 2x will give me minus 6x square. Upon splitting, I can write it as x square minus 3x plus 2x minus 6, which can be written as x into x minus 3 plus 2 into x minus 3, which can be written as x plus 2 into x minus 3. Now, the whole term can be written as x plus 2, which we already found was a factor, and x plus 2 into x minus 3. This is how we have factorized the cubic polynomial. Let's start solving exercise 2.3 questions. The first question asks us to determine if x plus 1 is a factor of the given polynomials. First polynomial is x cube plus x square plus x plus 1. How to find if x plus 1 is a factor? Now I have to take x plus 1 equals to 0, which gives me x equals to minus 1. Substituting x equals to minus 1 in the given expression gives me 0. So x plus 1 is a factor of this polynomial. Second one, x power 4 plus x cube plus x square plus x plus 1. To find if x plus 1 is a factor, again I substitute x equal to minus 1, which gives me plus 1 minus 1 plus 1 minus 1 plus 1, which is equal to 1. So x plus 1 is not a factor of this polynomial. Similarly, we need to find if x plus 1 is a factor of the third polynomial. Substituting x equal to minus 1 gives me, so minus 3 gets cancelled, minus 1 plus 1 gets cancelled, so answer is 1. This is not equal to 0. Therefore, x plus 1 is not a factor of the given polynomial. Fourth question, substituting x equals to minus 1 gives me minus 1 plus 2 plus root 2 plus root 2, which gives me 2 root 2. Therefore, x plus 1 is not a factor of this polynomial. In the second question, we are asked to use factor theorem to determine if g of x is a factor of p of x. In the first question, we have p of x equals to 2x cube plus x square minus 2x minus 1 and g of x is x plus 1. In order to find out whether this is a factor of this or not, we need to do x equals to minus 1 in p of x. Upon substitution, I get p of x value as 0. So, x plus 1 is a factor of p of x. That means g of x is a factor of p of x. Second question has p of x equals to x cube plus 3x square plus 3x plus 1. G of x equals to x plus 2. Here, I have to substitute x equals to minus 2 in order to find whether it is a factor. Substituting x equal to minus 2 gives me the answer minus 1, which is not equal to 0. That means x plus 2 or g of x is not a factor of p of x. Third one has p of x equals to x cube minus 4x square plus x plus 6. G of x equals to x minus 3. Now I have to substitute x equals to 3. 3 square minus 4 into 3 square plus 3 plus 6. This gives me a value of 36 minus 36, which is equal to 0. Therefore, g of x is a factor of p of x in this case. Find the value of k if x minus 1 is a factor of the given polynomial. Here, first polynomial is x square plus x plus k. We know x minus 1 is a factor. That means when you substitute x as 1, you should get 0 according to the factor theorem. Now substituting x as 1 and equating the polynomial to 0 gives me 2 plus k equal to 0. So the value of k will be minus 2. Second one is 2x square plus kx plus root 2. Again, substituting 1 in the place of x should give me 0. Now 2 into 1 square plus k into 1 plus root 2 should be 0. This gives me k equals to minus 2 minus root 2. P of x equals to kx square minus square root 2x plus 1. Substituting p as 1 and equating it to 0 gives me k minus root 2 plus 1 equals to 0. So k will be root 2 minus 1. P of x equals to kx square minus 3x plus k. Substituting x value as 1, k into 1 square minus 3 into 1 plus k equals to 0. So k minus 3 plus k equals to 0. 2k will be equal to 3 and k value will be equal to 3 by 2. Fourth question asks us to factorize some quadratic polynomials. Here I am going to use the splitting middle term method in order to factorize this polynomial. 12x square minus 7x plus 1. First, let it be like ax square plus bx plus c. Find a into c, that is 12 into 1 gives me 12 and b equals to minus 7. So we can use a hint in order to find these two numbers, that when multiplied should be equal to AC, that is 12, but when you add they should be equal to minus 7. We can check the factors of 12 for this, because A into C equals to 12. Now the factors of 12 are 1, 2, 3, 4, 6 and 12. I know that 6 into 2 is 12, but the difference of 6 and 2 won't give me minus 7. Now I know that 3 and 4 can be equal to 12. So 3 into 4 I can write as 12 and 3 plus 4 is also equal to 7. However, on multiplying I need to get positive 12, but upon adding I need to get negative 7. Now once you write in this form, then you can assign the sign according to what is suitable. Minus 3 into minus 4 will be equals to plus 12, whereas minus 3 minus 4 will be equal to minus 7. So once I finalize these numbers, I can split the middle term using these. Now splitting the middle term gives me 12x square minus 3x minus 4x plus 1. So I can take 3x as common for the first two terms and minus 1 as common for the next two terms. Now upon taking 4x minus 1 as common, I get 4x minus 1 into 3x minus 1, which are the factors of 12x square minus 7x plus 1. 2x square plus 7x plus 3. Writing it as ax square plus bx plus c, I get a into c equals to 6 and the value of b equals to 7. Now I am trying to find the factors of 6 in order to split the middle term. Factors of 6 are 1, 2, 3 and 6. 1 into 6 will give me 6 and 1 plus 6 will also give me 7. So I can write 1 into 6 and 1 plus 6. So I am going to use these to split the middle term, and I can split the middle term in the following manner. 2x square plus 6x plus x plus 3. Taking 2x as common in the first two terms, I get x plus 3. Taking plus 1 as common in the second two terms, I get x plus 3. Now I can write this as x plus 3 into 2x plus 1, which is the factorized form of 2x square plus 7x plus 3. Another example has 6x square plus 5x minus 6. AC is 6 into minus 6, which is 36. B is 5. Now I need to see factors of 36 in such a way that when I multiply I get minus 36, but when I add I get 5. First one, I can take 12 into 3, which will give me 36, but the difference or addition of 12 and 3 won't give me 5. Now 4 and 9. So 9 into 4 is 36 and 9 minus 4 is also 5. So I can use these. Let me write 9 4s are 36. 9 minus 4 will give me 5. But in order to assign minus, I need to get positive 5 here. So I'll assign minus to 4 here. Now splitting 5x as 9x minus 4x, I can write in this form. Taking 3x as common, I get 2x plus 3, and taking minus 2 as common, I get 2x plus 3. 2x plus 3 into 3x minus 2 is the factorized form. 3x square minus x minus 4. A into c will give me 3 into minus 4, that is 12, and b value is minus 1. Now looking at the factors of 12, in order to find these two values, I need minus 1 as the difference. So the difference between 3 and 4 can be 1, and if I write 3 into minus 4, that will give me minus 12, and if I write 3 plus minus 4, that will give me minus 1. Splitting the middle term, I have 3x square minus 4x plus 3x minus 4, and taking x as common, I have 3x minus 4, and taking 1 as common, I have 3x minus 4. So this is 3x minus 4 into x plus 1. Next question has factorizing of cubic polynomials. Now we know that this process will have a couple of steps more than the quadratic polynomials. The first step, however, is to multiply the coefficient of the first term into constant, that is 1 into 2, and think about factors of 2, which are plus or minus 1 and plus or minus 2. Now check if one of these is a factor. Check x equals to 1. Now that will give me 0. So x minus 1 is a factor. Now we have to perform long division of this polynomial using x minus 1. Writing down in this form, I have x minus 1 and the first term is x cube. So I have to multiply x square to x minus 1, that will give me x cube minus x square. So writing x square here and x cube minus x square here, and upon subtraction this will get cancelled and I am left with minus x square, and bringing this down will give me minus x. In order to get minus x square, I need to multiply x minus 1 into minus x. So I write that here and I get minus x square, minus into minus plus x. So I write down minus x square plus x. Upon subtraction, I eliminate x square, I have x, and I bring down plus 2. So it is minus 2x plus 2. Now I have to multiply minus 2 to this x minus 1. That will give me minus 2x plus 2. And writing that here will give me the remainder as 0. Now the next step is to further factorize x square minus x minus 2. Now the polynomial can be written as x square minus x minus 2 into x minus 1, and upon further factorizing x square minus x minus 2, I have a into c equals to minus 2 and b as minus 1. So I can take the factors of 2 as 1 and 2. So I can write 1 into 2 as minus 2, and minus 2 plus 1 will be minus 1. So this will be minus 2. So this condition is satisfied, and I'll split the middle term as x square minus 2x plus x minus 2, which will give me x minus 2 into x plus 1. X minus 1 is already a factor. So writing everything together, x minus 2 into x plus 1 into x minus 1. The next cubic polynomial we have here is x cube minus 3x square minus 9x minus 5. Now multiplying the first coefficient into the constant will give me minus 5. Factors of 5 are 1 and 5. So check if x minus 1 is a factor. Upon checking if x minus 1 is a factor, I substitute 1 in this polynomial and I get minus 16. So x minus 1 is not a factor. Check if x plus 1 is a factor. Now substituting x equals to minus 1 gives me 0. So x plus 1 is a factor. The next step is to perform long division of x plus 1 with this polynomial. So in order to get x cube, I need to do x plus 1 into x square, which will give me x cube plus x square. Writing it down and performing subtraction, I eliminate x cube. I have minus 3x square minus x square, which is minus 4x square. Bringing down the next term, minus 9x. In order to get minus 4x square, I need to multiply minus 4x with x plus 1, which gives me minus 4x square minus 4x. Now substituting that here, minus 4x square minus 4x, I eliminate the x squared term and I am left with minus 5x minus 5. So x square minus 4x. Now in order to get minus 5x, I need to multiply with minus 5. Upon multiplication, I am left with the remainder 0. Now I can write this polynomial as x plus 1 into x square minus 4x minus 5. The next step is to factorize x square minus 4x minus 5. Splitting the middle term, I need to get the numbers that multiply to minus 5 and add to minus 4. So 5 has a factors 1 and 5. If I do minus 5 into 1, I'll get minus 5. If I do minus 5 plus 1, I'll get minus 4. So I can split the middle term as x square minus 5x plus x minus 5. X into x minus 5 plus 1 into x minus 5. Taking x minus 5 as common, I end up with x minus 5 into x plus 1. So x cube minus 3x square minus 9x minus 5 can be written as x plus 1 into x minus 5 into x plus 1, which can be written as x plus 1 whole square into x minus 5. Next polynomial is x cube plus 13x square plus 32x plus 20. Now let's multiply the coefficient of the first term into constant. So 20 into 1 is 20. Let's write down the factors of 20. So the first factor is 1. Let me check if x plus 1 is a factor. So I have to substitute x equal to minus 1. Upon substituting x equal to minus 1, I get the answer as 0. So I can say yes, x plus 1 is a factor. Performing long division using x plus 1. Now taking x plus 1 on this side, I need to get the first term as x cube. So I will multiply into x square. So taking x square here and x cube plus x square here, upon subtraction this will be eliminated. 13 minus 1, 12x square, and bringing this term down, I have 32x. Now in order to get 12x square, I need to multiply this with 12x. Then I get 12x square plus 12x. So upon multiplying with 12x, I can write 12x square plus 12x. Subtraction eliminates this and I have 32 minus 12, which is 20x, and I bring this plus 20 down. So I need to have 20x. So I need to multiply x plus 1 into 20, which gives me 20x plus 20. Upon putting this 20x plus 20 over here, I get the remainder as 0. Now I can write this polynomial as x plus 1 into x square plus 12x plus 20. The next step is to factorize x square plus 12x plus 20. Taking a into c, I get 20. I have b as 12. Let's look at factors of 20 that can multiply to give me 20 and add to give me 12 or subtract to give me 12. Now I know 4 into 5 is 20, but 4 plus 5 is only 9. Then I know 10 into 2 is 20 and 10 plus 2 equals to 12. So I can write 10 into 2 and 10 plus 2. Splitting the middle term, I have x square plus 10x plus 2x plus 20. So x into x plus 10, that is common x in these two terms. Taking 2 as common in these two terms, I have 2 into x plus 10. So I can write this as x plus 10 into x plus 2. So the whole polynomial can be written as x plus 1 into x plus 10 into x plus 2. The last question of the exercise has the polynomial 2y cube plus y square minus 2y minus 1. The first step is to multiply the coefficient of the first term and the constant. Upon multiplying, I have minus 2. So 2 has factors as 1 and 2. Let's check if y minus 1 is a factor. Substituting y equals to 1 has given me 0. So y minus 1 is a factor. Let's perform long division of the polynomial using y minus 1. Now, taking y minus 1 here and the polynomial, first term is 2y cube. So, I need to multiply y into 2y square to get that 2y cube. Upon multiplying y minus 1 into 2y square, I have 2y cube minus 2y square. So, I start the multiplication with 2y square and this eliminates 2y cube. Y square plus 2y square as 3y square, and I am bringing this minus 2y down here. Now I have to multiply y minus 1 into 3y. That will give me 3y square minus 3y. Upon subtraction, I am left with positive y. Now I bring back the second term, which is minus 1, and I just need to multiply with 1 to get y minus 1. So I multiply with 1 and I have y minus 1 and the answer is 0. I can write this polynomial as y minus 1 into 2y square plus 3y plus 1. Factorizing 2y square plus 3y plus 1. A into c is 2 and b equals to 3. Taking factors of 2 and trying to find numbers that multiply to give me 2 and that add to give me 3. Now 2 into 1 is 2, 2 plus 1 equals to 3. So I can split the middle term as 2y square plus 2y plus y plus 1. This can be written as 2y into y plus 1 plus 1 into y plus 1. Taking y plus 1 as common, y plus 1 into 2y plus 1. The whole polynomial can be written as y minus 1 into y plus 1 into 2y minus 1. With this, we have come to an end to part 2.3 factorizing polynomials.